This is going to be the first of a few videos I'm going to make on load-bearing and non-bearing walls. Seems like some people out there are having a problem trying to figure out what I actually said in my most popular video. So I'm going to try and not just do it in one video, try and do it in a few videos from a few different angles. And again, if you have any questions or problems with any of these videos, feel free to leave a comment in the comment area. That will help me try and figure out what I'm doing wrong. And of course, I can always make another video. And again, I'm going to try and make a series of videos to provide you guys and gals with an explanation of how this thing actually works. What we're looking at here is the side view of a couple of exterior walls and a building foundation with concrete footings and of course ceiling joists. And I don't have the roof on it yet. This is just a side view. I'm going to go ahead and fill some stuff in here as we go. But again, we've got a concrete footing which is going to support the structural mass of the building. And then of course we have the building slab, which is basically going to be what we're going to be putting all of our furniture on, putting the floor on, and of course some of the other walls that are going to be non-bearing. And again, this would be something, if you were just to take a house and slice it in half at a section of the house, this would be what you would be looking at. This would be a section of a home. This is what's often referred to by architects and engineers as a building section. Here's how the weight is basically going to be distributed if there was pressure applied on the ceiling joists, and there will be from drywall. You're going to have some type of a ceiling, you're going to have lights, you're going to have things in the ceiling that are going to basically add to the weight of the building. And you can see here how the weight gets transferred to the sides through the exterior walls and down into the building foundation. And again, I'm sure there's an easier way that I could draw this, but bear with me. I hope this makes sense. This is basically how the weight gets transferred through a building and down to the building foundation. So when you're looking at you're looking at a ceiling or a cathedral ceiling, an open roof ceiling, let's say, where you're trying to figure out what's holding this up. Well, it's all of the structural framing members, which also add weight. Don't be confused here. All of these ceiling joists and roof rafters, all the drywall, the insulation, the roofing materials themselves, all add weight to the building and need to be calculated by a structural engineer to figure out what the sizes are going to be for all of the ceiling joists, roof rafters, wall studs, and of course the structural foundations, the concrete footings. Now here's a picture of a non-bearing wall. Now don't be confused, just because the weight is being distributed around this wall, it is not going through it, that it's a wall you can actually remove. It could actually be another structural member of the home, and this is where I think a lot of homeowners and do-it-yourselfers get confused. They go up and, hey, you know what? I'm allowed to remove this wall, and they cut into it, and all of a sudden remove the wall, and their building starts to lean. And I've seen that before. It's not going to be a good thing. A non-bearing wall simply means that it is not going to have a structural footing underneath it, and for the most part, the weight of the building, the roofs, the rafters, the ceiling joists is going to still be, it's going to be for the most part transmitted through other parts of the building. And in this picture right here, the weight is still being distributed to the outer exterior walls. Now here's an example of what a wall might look like that would be non-supporting or non-structural. And this would be whenever you would have the end of the ceiling joists connecting to another part of the building. It would either be connecting to a beam that would be supporting the weight, at one end, or it would be sitting on top of a wall. So it's got to be supported somehow. And if you run across something like this, where you have a wall that's in the center, there's a good chance that that's not going to be a structural wall. However, if you run across something like this, where the ceiling joists lap over a wall, you can see that the end of the ceiling joists on the right and the end of the ceiling joists on the left are actually sitting on top of this wall. There would be a good chance that this would be considered a structural load-bearing wall and would not be able to be removed without some type of structural engineering and redesigning of the structure. For example, the ceiling joists in the previous picture might actually be working something like this. They would lap over a bearing wall, and the weight would actually be transferred into a footing underneath the concrete slab. Next up, let's take a look at a side view of the rafters. Let's go ahead and add a couple of roof rafters in there. And of course, here's a picture of what those rafters would be sitting on the wall. And this is an example of the weight being distributed through the rafters down through the walls. Again, the weight needs to transfer through the building to the concrete footings, and this basically provides you with a pretty good example of what that would actually look like as the if you think about just a structural mass of something transferring to something else. Now here's something else you could run into, and that would be a load-bearing wall with another wall on top of it in the attic, let's say, supporting the roof. And here would be something where it would be supporting the peak of the roof or the ridge with some type of a bracing system. And if you had something like this, you poked your head up in the attic and you see this, there's a good chance you won't be able to remove the wall. And again, I'm trying to give you a better idea. The most common comments I'm receiving on these channels, the YouTube channels, is that people want to know how they can tell if a wall is load-bearing or non-bearing, whether or not they can remove it. So you're going to hear me mention that throughout the videos, and I cannot tell you which walls you can or cannot remove because I don't know what you're dealing with, and most of the time this is going to require a structural engineer also. Last but not least in the video, let's take a look at another non-bearing wall. And of course this would be a wall that would be dividing up a room in between two rooms, but would not be considered a load-bearing wall because again the weight would be transferring to other parts of the building. So I'm going to wrap that up. It looks like it's been 8 minutes. This is a long video for me. I will make other videos to provide you with other examples, and again I'm going to try and just throw everything I got at you and see if it sticks.